Yes, hello everyone, this is D. Chinnagokari. So in this video lecture, I am going to explain about the quantum numbers. So here what are the quantum numbers? So here quantum numbers these are nothing but they give address of an electron. So how we are having a particular address or a specific address. For example, when you book a online product in Flipkart or Amazon, there we provide our address so that without any confusion or difficulty that people may deliver that online product to us. So because they are having the our address. So here also we have 4 quantum numbers, so that by using these 4 quantum numbers we can find the location of an electron, which means these quantum numbers are address of an electron. So in that 4 quantum numbers we are having principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. So first I will explain. So what is the position of the spin, how the spin quantum number is used to locate an electron, and then after azimuthal quantum number, magnetic quantum number and spin quantum number. So from the Bohr's atomic model we already know, so atoms are having spherical shape. So and in this nucleus is present and electrons are revolving around the nucleus in fixed orbits. So our principal quantum number, first principal quantum number gives information about the orbit, in which orbit the electron is present, means in which cell the electron is present. And then after azimuthal quantum number. So azimuthal quantum number gives, for example, it gives information about subshell. It gives information about subshell, means so first we enter into the cell. For example, let us consider third cell. So here n is equal to 3, third cell. Okay. So we already know third cell contain S, P, D subshells. So here azimuthal quantum number will give information about in which subcell electron is present. Okay. So for example, let us consider here in P subcell the electron is present. Then after again we know P subcell contain 3 orbitals. So in which orbital electron is present, that information is given by the magnetic quantum number. So then after spin quantum number gives information about how the electron is present, whether it is present in upward direction or in the downward direction. So like this we can use these quantum numbers to locate an electron in the atom, which means they act as like an address of an electron. Okay. So first of all, principal quantum number gives information about shell. Magnetic quantum number, or sorry, azimuthal quantum number gives information about subshell. After entering subshell, orbital. After the orbital, orientation of electron. So this is briefly about the quantum numbers, and let us discuss one by one quantum number. First, principal quantum number. First one is principal quantum number. Principal quantum number. So principal quantum number indicated with the small n. So here principal quantum number gives information about it gives information. So first of all, indicated with the small n. So it was proposed by Niels Bohr. So it gives information about the shell number, or orbit number orbit number of electron. So here n has values, from 1, 2, 3, 4 and so on up to n and so on. So next, so it gives information about cell and cellular orbit of an electron, and also it gives information about size of shell. In the sense, size of the cell means maximum number of electrons. Size of the cell, maximum number of electrons in a shell, 2n square, and number of orbitals, that is n square, and this is the size of the shell. So here shell number increases, size also increases. Shell number increases, size also increases. For example, if n equal to 1 means number of orbitals, so n value, number of orbitals, maximum number of electrons. So here n value, for example 1 means number of orbitals, formula n square, here 1 square, that is equal to 1 only. Maximum number of electrons 2 into 1 square, according to formula 2n square, that is equal to 2. Next n value 2, number of orbitals 2 square, that is equal to 4. Maximum number of electrons 2 into 2 square, that is equal to 8. N value 3, that is 3 square, that is equal to 9. Maximum number of electrons means number of orbitals 9, maximum number of electrons 2 into 3 square, that is equal to 18. Likewise, it gives the size of the shell, and also it gives the information about energy. It gives information about energy. So next, so gives information about size of the cell and energy of shell. So here n value increases, energy also increases according to formula. Energy of nth orbit is equal to minus 13.6 into z square by n square. So here n is in the denominator, but here we are having negative value. So n value increases, this negative value decreases, which means n value increases. In positive case, energy is also increases. So here we already know n is equal to 1 means first cell, that is K shell, n equal to 2 means that is L shell, n equal to 3 means M shell, n equal to 4 means that is N shell, and so on we are having. So energy of the different shells. So here K is having less energy than the L is having less energy than the M is having less energy than the N, which means when you go away from the nucleus, size of energy is increases, and also size is also increases. Next to angular momentum of an electron. Angular momentum MVR is equal to NH by 2 pi, where N is the where n is the principal quantum number, which means n increases, angular momentum also increases. Angular momentum also increases. So these type of questions they will ask in the NEET level. Okay, likewise. Next, so this is maximally about the principal quantum number. So here, so diagrammatically how we can show. So here we already know, according to Bohr's theory, nucleus is present in the center of the atom, and whereas electrons are revolve around the nucleus. Likewise, so here n equal to 1, that is first cell or K cell from the side of the nucleus, and this is the second cell, third cell, fourth cell, and so on. We already know first cell is called K cell, second cell, third cell, fourth cell, and so on. So this is the diagrammatic representation of principal quantum number. Okay. Next, coming to one more quantum number, that is azimuthal quantum number. Okay. Second one, that is azimuthal quantum number. Second quantum number, that is azimuthal quantum number. So here azimuthal quantum number indicated with the L value. So here azimuthal quantum number, it is also called subcell quantum number. Azimuthal quantum number is also called subcell quantum number. So it was proposed by, so it was proposed by Sommerfeld. It was proposed by Sommerfeld. So it gives information about subshells. It gives information about subshells. So here these L values depends on n value, which means principal quantum number. So here L values are from L values are from 0, 1, 2, 3 and so on up to n minus 1. So these are the L values, possible L values. For example, if n value, L values, n value and L values. For example, if n is equal to 1, L value 0 only. If n equal to 2, L value 0 and 1. If L value 3, L values are 0, 1, 2. Likewise, so we can say. So here L equal to 0 means that is S subshell. If L equal to 1 means that is P subshell. If L equal to 3 means that is D subshell. If L equal to 4 means that is F subshell. Likewise we are having, so here n equal to 4 means possible L values are 0, 1, 2, 3. So when you show it in diagrammatically, so here we can come here. So here first cell contain only one subcell, that is S subcell. whereas second cell contain two subcells. See here 0 and 1 is possible. 0 means S subcell, 1 means P subcell, S P. Next coming to the third cell, 3 L values are possible, that is 0 1 2, which means S P D. And if n equal to 4 means 4 values are possible, they are 0 1 2 3, that is S P D F. So this is about azimuthal quantum number. And here maximum number of electrons in subcell, or first number of orbitals in subshell, that is equal to 2L plus 1. Number of orbitals in subcell, that is equal to formula 2L plus 1. So here L values and number of maximum number of electrons in subshell is given by 4L plus 2. 4L plus 2, or this formula sometime we can write as 2 into 2L plus 1. Okay, see for example, so now let us see in this tabular form L values and number of orbitals, maximum number of electrons. Number of orbitals formula 2L plus 1, maximum number of electrons formula 2 into 2L plus 1. So here L equal to 0 means 2 into 0 plus 1, that is equal to 2 into 0 plus 1, that is equal to only 1, means S subcell contain only one orbital. And maximum number of electrons 2 into 2L plus 1, here 2L plus 1 value is 1, so that is equal to 2 into 2L plus 1 means 2 into 1 means 2. Maximum number of electrons here we can keep, means we can fill, that is 2. Next, if L equal to 1 means, number of orbitals 2 into 1 plus 1, that is equal to 2 ones are 2 plus 1, that is 3. Maximum number of electrons 2 3s are 6, means P subcell contain 3 orbitals, maximum number of electrons present in it, that is 6. Here L equal to 3, so 2 into 2, so L equal to 2 means 2 into 2 plus 1, that is equal to 2 2s are 4 plus 1 5 orbitals it contains. So 5 orbital means maximum number of electrons we can fill 2 into 2L plus 1. So 2L plus 1 value is 5 into 2 10. So likewise we can fill the maximum number of electrons and orbitals. Next, angular momentum in subshell. Angular momentum in subshell is, that is MVR. MVR is equal to square root of L into L plus 1 H by 2 pi. So this is the angular momentum in the subshell. Okay, so this is about azimuthal quantum number. Next, coming to magnetic quantum numbers. So third one, that is magnetic quantum number. So if you want to make notes, you can write by making a pause and we can write. Yes. Another third one is, that is the magnetic quantum number. Magnetic quantum number indicated with ml. So it was proposed proposed by, it was proposed by land. So this magnetic quantum number gives information, it gives information about, it gives information, it gives information about orbital, about orbital. So here magnetic quantum numbers ml value or sometime ml values are depends on L value. So here possible ml values are minus L to 0, 0 to plus L according to the formula. So that is 2L plus 1. So this is the formula to find out number of ml values, number of ml values. So here, so for example L value and ml values, L value and ml values. So here first L value we already need to start with 0. ml values are according to 2L plus 1 value is possible, that is according to 2L plus 1 formula. So 2 into 0 plus 1, 2 into 0, 2 into 0 plus 1, that is 1 value is possible. What is that 1 value? That is 0, 0 only. Means S subcell contain, so we already know L equal to 0 means that is S subcell. S subcell contain only one orbital. So ml values are nothing but number of orbitals, only one orbital possible, that is 0. So here see, this is the S subcell contain only one orbital. So here L equal to 0, ml is equal to 0, and what is the shape of S orbital here? That is spherical shape, or it is called sphere. X, Y, Z. So this is the shape of S orbital, that is spherical shape. Next L equal to 1 means that is P subshell. So here ml values means number of orbitals according to formula 2 into 1 plus 1, that is equal to 3 are possible. So then what are that 3? We already know that is minus L to 0, 0 to plus L. Here L value is 1 means minus 1, 0, plus 1. So these are all possible, means P subcell contain 3 orbitals. So that is P L equal to 1, that is P subshell contain 3 orbitals. So that is Px, Py, Pz. So here we can write, here this is the minus 1, 0, plus 1. Anyway here no, it is not a mandatory of writing plus 1 here, 0 here, minus 1 here. You can write plus 1 here and minus 1 here, 0 here also, no problem. And what is the shape of the p orbitals? P orbitals are having, p orbitals are having are in dumbbell shape. So which we used to build some muscles like in the gym center, that is dumbbell. Okay, so here we have 3 p orbitals, that is px. So it is in the x axis, y, z. Okay, so x, y, z. So this is the py and this is the pz, x, y, z. Okay, this is the p orbitals in the dumbbell shape. P subshell is having 3 orbitals. Next, if L equal to 2 means that is d subshell. So d subshell, so number of ml values, that is number of orbitals, that is 2 into 2 plus 1, that is equal to 5, means 5 values are possible. So what are that 5 values means they are from minus L to 0, 0 to plus L, means L value is 2, which means minus 2, minus 1, 0, plus 1 and plus 2. These 5 values are possible. So here L equal to 2 means that is d subshell. D subshell. So here d subshell contain 5 orbitals. So what are that 5 orbitals? 1, 2, 3, 4, 5. This is d xy. So xy. So this is the d xy. So it is having double dumbbell shape, means d orbitals are having double dumbbell shape. So this is the d yz, d xz, this is the dx square y square, and this is the dz square. So here dxy, dyz, dxz are having the same shape. So instead we change this Cartesian axis, this xy axis we will change. For example, if you write x and z, this will become dxz orbital. If you write y and z, this will become dyz orbital. But dx square y square, it is also having dumbbell shape, but the orbitals are present on the axis. Likewise, this is the dx square y square orbital, and dz square is having one different shape, that is one dumbbell and 2 circles. So this is the shape of dz square orbital. So here it is also called baby suture shape. Baby suture. Baby suture means so which we are used to feed the very small infants medicine or any milk. So this is the baby suture shape, right? So overall d orbitals are having dumbbell shape. Next, if L is equal to 3 means that is f subshell. So here 2 into 3 plus 1, that is equal to 7. 7 values are possible. What are that 7 values? We already know they are from minus L to 0, 0 to plus L. So L equal to 3 means we will start with the minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So these 7 values are possible, which means L equal to 3 means that is f subshell contain 7 orbitals. F subshell contain 7 orbitals. Okay, so 1, 2, 3, 4, 5, 6, 7. So these are represented as f x, y, z. Like that, some representations are there. That representations are not required. And if anybody asks what is the shape of the F subshell, that is complex shape. Complex shape or it is also called double dumbbell, double dumbbell. So like triple D shape, like tribular it is having triple D shape, double dumbbell shape. So this is about magnetic quantum numbers. Magnetic quantum numbers gives information about the subshell. So here in the D subshell, in the F subshell, this is -3, -2, -1, 0, +1, +2, +3. So this is about magnetic quantum number. Okay, magnetic quantum number gives information about the subshell. And the last one, that is the spin quantum number. So here spin quantum number, what is a spin quantum number? This is the fourth quantum number, spin quantum number. So here spin quantum number indicated with the S, or sometime it is represented with the MS also. So it was proposed by Uhlenbeck and Gaudsmith. Uhlenbeck and Gaudsmith. So it gives information about orientation of electron. Orientation of electron means whether it is in the upward direction or in the downward direction. This much only it gives information. Means upward direction means plus of, downward direction means minus of. Means only two spin quantum numbers are possible for electrons, that is plus of and another one is minus of. So technically if it is upward in direction, that is called plus of, and it is in downward direction means that is minus of. And here angular momentum mvr is equal to square root of s into s plus 1 h by 2 pi for this spin quantum number. So here according to this orientations, means two orientations are only possible. So an orbital can maximally accommodate only two electrons. One is upward direction, another one is downward direction. So according to this, S subshell is having only one orbital. Maximally it can accommodate only two electrons. One is upward direction and another one is downward direction. And here P subshell is having three orbitals, means it can maximally accommodate 6 electrons. D subshell is having 5 orbitals, it can maximally accommodate 10 electrons. F subshell is having 7 orbitals, 7 to the 14. So it can maximally accommodate 14 electrons. So this is the enough information about the quantum numbers. Okay. So in the next videos I will explain about some different rules while writing the electronic configuration. Thank you. Yes.